Good morning, everyone. Good evening, good afternoon, whatever your time zone, wherever you are, welcome. This is AI Talk, and I am your host, Kevin Crane. Welcome to the show. Today, we will be discussing the topic of AI adoption in the chemical industry and what lessons and techniques we can transfer to other industries. Look, it's no secret that organizations of all kinds face increasing pressure to leverage AI effectively. Yet research shows that just 15% of AI projects are successful, while others, 85%, fail. We've discussed this failure rate on the show in the past, but what about the 15% that are successful? There are important lessons we can learn from successful early adopters. And one segment to consider is the chemical industry, where early adopters have reported significant benefits, such as reducing unplanned downtime through predictive analytics and maintenance, accelerating R&D, and improving operational efficiency across production processes. For chemical companies, these advantages have translated into faster innovation cycles, lower operational costs, improved product quality, and stronger competitive positions in the market. So, what can we learn from these successful early adopters, and which lessons from the chemical industry might we transfer into other sectors? In this session, we'll explore three critical areas to consider. First, we'll talk about identifying high-impact AI applications. We'll explore where AI can drive the most meaningful results. We'll talk about building a strong AI foundation and the essential building blocks for successful implementation. And we'll also touch on scaling AI across the organization. Look, real success requires expanding AI beyond siloed processes. At the end of the day, I hope you will have some important insights and strategies to harness AI's full potential in your organization. We're going to dive in just a second, but before we do, I want to say thank you to everyone attending today, and that includes folks joining us on LinkedIn. Hello, everyone. And hello, everyone joining us today on Zoom. Thank you for being with us today. During today's discussion, we want to hear from you too, so I'd like to encourage everyone attending today to participate. Please join in with your comments in the chat section if you have a question along the way. Look, just jump on in and I will attempt to get some of the questions, your questions and comments into the flow of the show. And we may have a few minutes also at the end for your questions. All right, let's jump in with a great panel of guests today, starting with Kyle Killebrew, COO at Citrine Informatics. Kyle, are you with us?
Hi there, Kevin. Great to be
Hello,
with you today.
Kyle. Welcome aboard. Where are you calling in from?
Ann Arbor, Michigan.
Ann Arbor, Michigan. Wonderful. Thank you for joining us today, Kyle. Also with us today is Peter Van Herzel, head of BU Coding Solutions at Dorfner. Peter, are you with us?
Hello, Kevin.
Hello, Peter. Where are you calling in from today?
I'm at the moment I'm in Frankfurt.
Frankfurt, all the way from Frankfurt. Well, wonderful. It is great to have you with us, Peter. Thank you so
Thank you.
much. And also joining us today is David Thomas, Director of Research Development at Syensqo. David, are you with us?
I'm here, Kevin.
Hello,
Good to
David.
talk to you.
Welcome aboard. Where are you calling from?
I'm in Atlanta, Georgia today.
Atlanta, Georgia. All right, wonderful. Well, Peter, David, and Kyle, thank you so much for being with us today. I'd like to start our discussion off today by pointing our attention to an article published recently from McKinsey. It talks about how AI enables new possibilities in chemicals. The McKinsey article argues that chemical companies can unlock huge value by embracing AI across R&D, operations, commercial functions. Key use cases include discovering new molecules and materials, accelerating formulations, improving customer acquisition. For early successful adopters, AI can boost maintenance productivity, throughput, supply chain resilience, just to name a few. But McKinsey warns us that we all need strong data foundations, digital infrastructure, and change management capabilities to make it all work. So I'm curious what the panel thinks about this article. Kyle, I'd like to start with you. What are your thoughts on the article?
Interesting article. The things that stood out to me were one, when it was written almost a year ago, um, on my daughter's birthday, as it turns out, which is notable to me because it's talking about what I think a lot of people would agree are sort of tectonic potentials or tectonic opportunities. And why it's notable that it was a year ago is the landscape from my experience, and I imagine David and Peter would agree with this, has shifted pretty dramatically in just that year. A lot of what this article identifies as potential is no longer potential, but it's reality, at least from the experience that Citrine has with its customers. And I think it's true to the experience at ScienceCo and Dorfner. And what has taken it from opportunity or potential to reality. One thing that the article highlights, which I 100% agree with, is the companies that are doing this well, and there are a few of them on the in the conversation today, are the ones that are treating this as a transformational opportunity. Right? This isn't a side project. This isn't something that companies are sort of handling off the side of their desk per se, but they're treating it as core to their sort of go forward strategy, right? And I think McKinsey in this article speaks to that really well. And I imagine David and Peter would be of a similar mind based on their experiences.
Now, David, from your perspective at ScienceCo, what are your thoughts on the article? Did it miss anything important we should consider?
I also agree that the article was pretty interesting. I think a lot of companies, including ours, have a lot of proprietary information in internal databases that AI enables us to really take advantage of. It's really about better leveraging investments that have already been made in the past and being able to extract more value from them. One thing that is possibly missed that I think is still to be worked out in the industry is there's a lot of nominally publicly available information, but that's behind paywalls from the different journals and things that own them. And so that's a piece that I think still needs to be worked out. I have a relatively high degree of confidence that it will, but as of yet, I think it's limiting the full potential that we could all imagine from these sorts of tools.
And Peter, the article mentions improvements in things like productivity, customer acquisition, supply chain. Are there any other areas that other industries should also consider?
Yeah, I think, well, they've identified the most obvious ways to get some improvements in the organization, supply chain, R&D, develop new products, and so on. We're sitting on so much data, and most companies don't even have an idea of the treasures they have hidden sometimes within their data. So I think if you take them to an AI platform, you make a model, you can get these things out. But things like the trust issue, what do we do with data? Where's the data coming from? Are all companies individually going to develop a platform and develop a model, or do we find a way to work together and get more data into the same model? We'll be able to leverage the possibilities dramatically. So I think that's the opportunity for the future, and it's a question that is not answered at this moment. How do we deal with data exchange between companies? So that's something that is, to me, key to further development of the AI opportunities in the industry.
Yeah, and Kevin, if I can just build on a point that relates to both what David and Peter have said, a lot of people will focus, and McKinsey included, on the source of data, and we'll think about in the case of R&D, the experimental data they have as sort of the primary focal point for their attention. I think the folks that I've seen that have more success here are thinking a little bit more comprehensive about all of the potential inputs. It's not just necessarily experimental data. They're thinking about it's experimental data, it's publications behind paywalls, to David's point. It's technical data sheets, safety data sheets when we're talking about products and chemicals, but it's also the knowledge that the product developers, especially the experienced product developers that work at these companies, have about the chemistries that they're working on. That's a massive, per se, repository of data that isn't really acknowledged in the McKinsey article. To my experience, it's rarely acknowledged, but we at Citrine and I think based on experiences with ScienceCo and Dorfner, this is also true, see that as also a massive opportunity to sort of power AI and make it more capable at our companies.
The article is How AI Enables New Possibilities in Chemicals. It is from McKinsey. It's here in the chat feature over here to the side. If you'd like to take a look at it, we'd like to get your thoughts on the article as well. Did it miss anything important that we should consider? What are your thoughts about some of the transfer from the chemical industry into other industries when it comes to AI adoption? So, all right. Well, very good. Well, let's move on, gentlemen, to our first discussion point today. Excuse me. And that is identifying where AI can make a high impact difference. It's estimated that AI adoption in chemical R&D can reduce experiment cycle times by up to 30%, and of course unlocking faster innovation. So let's pinpoint the areas where AI will deliver the most significant operational and business impact. Now, Kyle, from your experience in materials informatics, where have you seen AI deliver the most significant impact in chemical processes, and why?
At Citrine, we really put a lot of effort and focus into attempting to measure value, right? Sort of per se putting our money where our mouth is in making the claims about our software that it drives value for our customers. Especially in the early years of applying AI, the biggest impact is productivity. And that's probably not a shock to a lot of the folks joining the call today. The key thing that I would call out there is you can measure the productivity. You have to measure the productivity, because when you start to measure the productivity, it's pretty astounding, especially once you start to scale AI across organizations. And specifically what that looks like in chemicals, especially in chemicals R&D, but it's also true in other other functions of chemicals like manufacturing operations, is things that yesterday took you, for sake of example, months to complete will now take you weeks. Things that took you weeks will now take days, because the AI can help you to get to those outcomes faster by sort of considering all the potential variables that went into driving those outcomes historically, and being able to navigate to the answer a bit faster. That is in the early days of applying AI, the first year, 2 years, 3 years. That's what drives the biggest value. Once the AI starts to really learn at scale across your entire organization, that's when you start to see it driving innovation, right? More competitive products that get to market faster. So for anybody that's in R&D, those are the really big growth drivers for any one of our companies. When you can create a new product that's significantly more competitive than anything that's already out on the market, and you can get it to market long before your competitors do, right? So just the real quick summary is, first few years, productivity is typically the biggest driver, as well as maybe some cost engineering. Later on, 2, 3, 4 years into adoption and scaling, now innovation is starting to become a really big driver.
And Kyle, you mentioned measure the productivity. I think if you can't measure it, you can't manage it. But innovation is more difficult to measure. How do you identify those early wins or the wins in innovation and measure that and demonstrate that across the organization?
Yeah, it's a great question, and it sort of hits on, I think, Kevin, you may have used this phrase earlier, certainly in the McKinsey article, change management. What measures gets managed, to your point. This is one of the difficult things about AI adoption today, is especially in R&D, it requires sort of a new paradigm of measurements, things that we haven't measured before, but now if we really want to understand the value that AI is driving, it's important to do so. How do you measure innovation? Actually, I would disagree slightly that innovation is maybe a little bit easier, because innovation for a lot of these companies, the way they would measure it, to my experience, but actually David and Peter are probably better suited to answer this, is any one of these companies have an estimate of if they achieve a certain level of performance on a product, there's an expectation around the value that would have in the market, right? And oftentimes that's coming from, say, the marketing function at that company, right? So the way you measure it, you hit those performance targets in R&D for a new product, and then if you're capable of scaling and get to market, you're able to see, did we actually, one, get to the performance targets, two, did we get it to market? Once it got to market, did it achieve the value that we expected it to? Productivity is actually the thing that more often a lot of Citrine customers have difficulty measuring in R&D, because what you have to sort of posit is, how long did it take us to do something historically? How long does it take us today? And if you weren't measuring it historically, it's now you have to sort of come up with hypotheticals and measure against that.
Now, Peter, tell us a little bit more about how this plays out at Dorfner. Which areas in coding solutions are currently delivering measurable improvements from AI, and how do you prioritize those?
Well, the thing is, first, that we are a producer of raw materials for the coating industry, construction, composites, and so on. So we've seen that the last couple of years through COVID, through energy, through the sustainability developments that we're seeing right now. Some materials were not available, then materials were available, but transportation was not available. Then it became too expensive. There was the energy crisis. So business has become more and more complex for us and for our customers. So every requirement that comes on top increases the complexity of the system exponentially. So for us, it was not really a matter of measuring productivity or measuring success rate of R&D. It was about mindset. I heard earlier, Carl said change management. So we transformed the company from a product-driven company to a solution-driven company. And I think that's been the most important lesson we took from the first couple of years of our journey with AI. We are changing the mindset of the company, and that's much more important than figuring out how much money one specific development brought us. Without AI, we would not have been possible to keep up with the market changing so quickly, and we would not have been for sure able to make the basis for the future.
You mentioned that without AI, it would have been hard to keep up. How do you folks evaluate which processes are ripe or ready for AI versus those better left with traditional methods?
Well, we have in our R&D, we have a lot of data because we've developed products ourselves. So all this data is usable in AI to develop new products. We've also developed paint formulations, coatings formulations for our customers who also have those in our system. So if we combine the two, we can have better products to develop better formulations for our customers. And in the third stage, we are integrating our production data, which is also a collection of data from the last 20, 30 years that we can add to the system and afterwards not only decide which product would be best for which solution to present to our customers, but also how we produce it. So we go from the very start in our mine towards the very last step of our customers' coatings formulations. We are covering the full range, the full journey of our raw materials until the final pot of paint. So that's for us the most important application.
Now, David, what criteria do you use to determine which research and development tasks benefit most from AI intervention?
Yeah, this is an important question because, to me, the first thing you need to consider is which tasks are really the rate limiting step in the overall process. You could easily apply AI, like any efficiency tool, I guess, to the wrong step and derive no benefit. But once those have been identified, we actually have seen 3 areas where it can make a big difference. And one that isn't talked about a whole lot is in really knowledge transfer as you're having more experienced employees approach retirement and you have new hires coming on. The AI enables really the new employees, especially to gather the information from a broad range of sources and have it at their fingertips, so that they start to perform as an employee with several more years of experience almost out of the gate. And you can see that very easily in the reviews of those employees' performance, and the ones that are actively using AI are performing at a higher level. There's another one where you're just reducing the number of iterations it takes to get to an endpoint. And in our case, at least, for a long time, we have been measuring how long it takes to achieve a successful product development. And so you're able to see the improvements for the projects that are actually employing AI as opposed to those that didn't in the past. And then the last level of success, I think, is where we have insights that we gain with AI that we wouldn't have otherwise. And those actually require, I think, the people working on the project to raise their hand and say, yes, I just wouldn't have thought of this without that. And we've had those as well. Personally, I would have thought that it would take longer to get there, but even in some of the very early stages, we have examples of where that has actually happened, so that we have a product we just wouldn't have had without the tool.
Now, David, we have a question coming in from our attendees today. I was hoping you could help me with it, and certainly Peter and Kyle jump in as well. But Marco is asking, in a highly regulated industry like chemicals, how do you strike the right balance between moving fast with AI innovation and still making sure you're meeting all the compliance and safety requirements? David, do you have a thought for Marco?
Yeah, I think it depends on how you're applying it, for sure. If you're developing something that requires testing to, for example, achieve compliance, that is something that you cannot easily shorten through AI, if that's the rate determining step. But in many cases, that isn't. You may be using ingredients and things that are already approved, and so that if you're doing a formulation, for example, that's not an issue. But it really goes back to what I said at the beginning. Focus on what's the rate determining step. If the rate determining step is something compliance oriented, then maybe that's where you want to try to apply the AI.
All right, very interesting. All right, very interesting. Well, let's keep moving, gentlemen. I want to move us on to our second discussion point today, and that is simple building blocks and strong foundations for AI. Studies show that 60% of AI failures are caused by poor data quality or a lack of foundational infrastructure. This emphasizes the need for strong preparation. So let's look at the key building blocks and steps that we should follow. Kyle, what foundational steps should a company take to prepare its data and infrastructure before scaling AI?
So what we advise a lot of our customers is I try to keep it simple, try not to reinvent anything here. And I sort of mentioned it before, at nearly every single one of our customers, and this is going to be true for nearly any established company, they've done some type of transformation before. They have probably a transformation playbook. And I know the question is more around preparing your data, but where we end up focusing our advice is trying to be comprehensive about what it takes to undertake this transformation. And a lot of it gets back to the change management, because if you're going to prepare your data, there's probably going to be a few people involved at your company that are doing that data preparation. So, when you think about a transformation, are there leaders identifying this task of AI adoption as a priority? 1. 2, do you have resources set aside? In some companies that have been particularly successful, they establish a tiger team, an AI tiger team, as an example. Do they have that tiger team, those resources set aside to make sure that they're making progress in accordance with, third item, a plan that they've laid out in terms of how they're going to adopt and scale the impact of AI? And then, of course, we were saying it before, David and Peter both hit on it as well. What are our goals and how are we measuring our progress to that? So it's not only a plan, but how are you measuring progress against that plan? Going back to the question about data preparation and infrastructure, honestly, Citrin's point of view is get started. Don't let data be the barrier, because the honest truth about chemicals is there's not a lot of data to begin with, right? If you spent all of your time worrying about creating, collecting, and organizing data, you never get started using AI. And really, the answer from our point of view is being agile about it. Use the data that you have. Use the data that's most readily accessible, that's not going to be a bottleneck. Start training AI on that data, get some results, get more data into the software, get more results, get more data into the software. So, the quick summary version is, don't spend all of your time focused on the data in the infrastructure up front. There's minimal preparation, generally speaking, that's necessary in order to get started. The advice is get started with what you have.
Now, Peter, Kyle mentioned, well, certainly the need for data prep, but also the importance of change management and the people involved. Indeed, it's the people that really make things happen. From your perspective, what internal processes and skills are critical for creating a strong foundation for AI in manufacturing?
Yeah, I think apart from the data, obviously you need the data, and we took the advice of our partners of Citrine not to be too much concerned with the data in the beginning, because otherwise you indeed don't get started. You need the know-how as well, because only with data a system is not going to build a model. So you need to be able to have the right people correct the model. Push the model in a certain direction to get it perfect. And then I like the Tiger team of Kyle. So I guess I was in the Tiger team from the beginning. So you need to have a group within the company. It should be priority to the company. The company should be willing to spend money on a project that cannot be treated as a classical ROI project, where you know beforehand what you'll invest and how quickly you're going to earn the money back. So this needs to be backed by the organization. And within this organization, you can't motivate the whole organization at once. So I would say within the organization, we need to have a well-motivated Tiger team that's starting, that drives the project internally. And I think then you can quite quickly get the first successful steps, and that will keep the ball rolling and making it bigger and bigger within the organization. So then it goes more or less automatically as an internal driver.
It seems to me that when we think about building blocks for AI success and implementation, we can think of really three things: data, people, and governance. Now, David, from your perspective, what data governance or quality practices are essential for successful AI implementation?
It's a great question, Kevin. And actually, one piece of advice I'd also have for anybody that is thinking about embarking on this journey would be to, as much as possible, have a standard structure to the data that you're generating today. So at least any experiments from today and forward are in a format that's readily digestible by any tool that you may choose to use in the future. That, in many cases, certainly for us, was already an adjustment. But the larger domains that you can have that are structured in a similar way, the more easy it'll be in the future.
All right, very good. We are here today with Kyle Killebrew from Citrine, David Thomas from Syensqo, and Peter Van Hersel from Dorfner. We're here talking about AI adoption in the chemical industry and how those lessons and successes can be transferred over into other industries. If you have a question or a comment for our panel today, just pop them here into the chat feature, and we'll have some time to get some of your comments and questions into the flow of the show. All right, gentlemen, in the time that we have remaining, I'd like to move us on to our third discussion point today, and that is scaling AI beyond siloed processes. Now, while pilots can be successful, only 15% of AI initiatives scale effectively across organizations, often due to accuracy, integration, or security challenges. So let's examine strategies to expand AI initiatives beyond those isolated projects. Now, Kyle, What strategies have you seen proven effective for expanding AI from a pilot or a siloed use case to an enterprise-wide adoption?
A lot of the advice that I'd offer here goes back to the previous comments around running this like you would a traditional transformation, where you have leadership engagement, prioritization, resources, tiger teams, governance, to the last point that you, Kevin, and David were making. Sort of maybe double clicking into that, I agree. I think David's point about picking places that have high efficacy, or thinking about where you're going to have high efficacy in applications, is an important one in how you roll this out, sort of how you cascade across an organization. So if you started a pilot, best practices, you sort of pick a beachhead, you pick the highest efficacy area to start the pilot, so that you can show success, build confidence, test and evaluate whatever AI instruments, tools that you're using. And you know, when I say efficacy, the way that we often think about it is, where are there use cases that, if they are successful, will drive high value, but it won't be too difficult to get started. So there's a little bit of data to start with. You've got potential users of the AI tools that are excited about using the tool. You can allocate those resources, a portion of those resources, to driving this forward. Those are the high efficacy areas. And then you kind of just stratify across the organization, highest efficacy to lowest efficacy, and you sort of use that methodology to determine your prioritization of how you roll it out. In our customers that have the most successful adoption, that's one of the primary guiding principles that is driving that adoption and scaling.
As we expand across the organization, rolling it out and cascading it, as you say, I'm curious about maintaining model accuracy and integrity. How do you maintain model accuracy and integrity when scaling AI across multiple teams or multiple facilities?
It was accuracy and what was the
integrity.
second one?
Yeah. In other words, how do I ensure my models have integrity and accuracy as I scale across?
David sort of made this point earlier. You know, it depends on what we're talking about. I think in a lot of applications in chemicals, certainly where Citrine spends a lot of its time, there are quality control processes that are in place that AI today is not going to replace. So in R&D, what that means is you might do the research to develop a new product, a new formulation. That new formulation is still going to go through the same qualifying tests that it would have without using AI. The difference with AI, and I think David sort of made this point earlier as well, is that maybe those qualification tests go faster because you were able to screen and predict for product candidates that were higher efficacy for passing those qualification tests. They're less likely to fail those qualification tests. I think the same is true. You can make similar statements about what happens in manufacturing. When you're running a process line in chemicals, there's still QC processes and check that every now and again are checking whether what's being run on the line is within the specifications that it needs to be, right? So the short answer to that question is, you know, make sure that you're not taking the brakes off when you start scaling AI. Make sure that you still have the quality control processes in place that you trust, and will ensure that whatever AI is recommending continues to hit the level of accuracy and integrity for the product that you need it to.
And Peter, let's continue to explore this idea of rolling it out and cascading it. When rolling out AI beyond these sort of isolated projects or pilot projects, how do you ensure employees continue to trust and engage with the technology?
Well, that's something that goes automatically when you get more successful. So we started, we did not have a plan to roll out the technology and the whole company. We started 4 years ago. It was still at the very beginning of AI, and the first developments were released. We had no plan. We had a vision. We thought, okay, we were sure that we would need AI. That AI would help us to be successful, to answer the questions that become more and more complex. And we started in one specific area where we had good data, where we had motivated people. And we gave them this project, and we said, look, here we are going to have a look at AI and see what it can bring us. These people developed something incredibly successful within the organization, and then we started to spread the word. Started to train our colleagues internally, check what we can bring for the other business units within the company. We had a project with customers. We could write success stories from there. And when the word spreads internally, it goes much faster and it's much more convincing than when the boss tells, look, this is the way we're going and everybody needs to hop on board. So we developed a success story within the company, and then everybody hopped on board, and it's kind of something that develops itself.
Now, David, we're talking about scaling AI across the organization. How can AI systems be scaled without introducing things like bias or errors that compromise our research outcomes?
Yeah, I mean, I at least in our experience, I think the best way to look at it is we always have to check the results of any experiments you do, including those that are suggested by AI. So, and we have experts, experts in the chemicals and the chemical industry and all the sciences that we always have had, that will look at the results, sometimes skeptically, sometimes not. But in any case, we always will still need to test. So that's the most important thing. And where these errors arise is just an opportunity to better train and refine the models. And that's the way we need to look at it, I think, especially in the early stages.
All right, gentlemen. Well, it has been a fantastically fascinating discussion today. Before I let you go, I just want to ask one question to everyone. What are some of the most common mistakes that you see organizations make when setting up AI foundations? And what's the one common mistake that we should all avoid? Peter?
I think checking data quality and data quantity over and over and over. Just take the data and start. And also try to see it as a ROI kind of project. You'll also fail because you start in the journey with AI, you don't know what's coming out of it. So try to avoid working too long on the data, and try to avoid seeing it as an ROI kind of calculation, because that's not the way to success from my experience.
And David, what's the most common mistake that you see, and how should we avoid it?
I think the most common mistake that I see is actually underestimating the change this is for our people. A lot of the resistance actually comes from highly skilled, highly accomplished people that don't see the value of AI at the beginning and may see it as just extra work. So we need to make sure we carve out the time for them to learn what is really a new skill. And in many cases, it may be people that haven't really been forced to learn a new skill for a while. So just allowing the space for that and rewarding them for taking the time to do that, I think is critical.
And Kyle, what's the most common mistake that you observe, and what should we do about that?
I was smirking because every time I thought of the answer, that Peter or David stole my thunder. So
Always.
I'm on my feet here. The additional thought that I'd have, it goes back a little bit to the previous question, which I realize sort of presumes that all AI or it maybe suggests that all AI is a black box, right? How do you check and ensure that it continues to be accurate and the integrity is high? I definitely agree with David and Peter's point that a lot of it is you're checking the outcomes. Are the outcomes still what you want? And this is also true for avoiding bias. The mistake or advice that I would offer is your assumption, common assumptions around data necessities, common assumptions around the AI being a black box. Check your assumptions. Don't settle, right? If you need for your company a tool that has a certain level of transparency, that demands a certain level or a minimal level of data preparation, there are lots and lots and lots of tools out there today, and there will be many more probably within minutes of this conversation ending. There's a lot of effort, there's a lot of money, there's a lot of resources going into AI development. It's hard to find the right solution, but don't just assume that, whatever is common knowledge or whatever you were able to find on the first Google search or Chat GPT synthesis is the right answer. Do a little bit of work to get the answer, to get the tool that is going to work best for your organization.
Now, Kyle, we have a comment or a question coming in from our audience. In the time that we have left, I'm hoping you can help me out with this. A question from Lauren. And Lauren, thank you for your contribution today. Lauren asks, what can the pharma industry learn in scaling complex systems to roll out AI effectively? Kyle, what are your thoughts on pharma?
Sorry, Lauren, this one's a little out of my depth. I don't have a lot of experience in pharma. I don't know if David and Peter do. And in fact, I almost would invert it and say a lot of what materials informatics, which is a fair bit of what we're talking about here and how you can apply machine learning into material science and chemistry, a lot of some of the learnings there came from bioinformatics, right? Which I think sort of predates the genesis of materials informatics. So some of that answer might be, what can chemicals learn from pharma? In terms of what pharma can learn, I imagine there are a lot of lessons from what we talked about that are very generalizable in terms of how to think about and deal with your data, how to think about and deal with change management. I think Peter and David both made excellent points about change management in terms of getting a successful case and advertising it to get the rest of the organization excited about it, as Peter talked about, and then also really being thoughtful about the folks in the organization that you need to participate and use this software and their mindset towards using the software and what will be necessary to change that mindset, right? I think I would imagine those are great generalizable bits of advice that apply into pharma as well as other industries.
All right, very good. We are here. This is AI Talk. We are here with Kyle Killebrew, David Thomas, and Peter Van Hersel. We've been talking about AI adoption in the chemical industry and how those successes can translate over into other industries. Gentlemen, it has been a great discussion today. Thank you so much for your time. Before I let you go, I'm hoping that each of you could please provide us with one quick action item that our viewers can use to take advantage of the ideas and advice today. Peter, do you have an action item for us?
Well, I think if you don't believe in the technology, then it will be difficult. But if you believe in the technology, then take your data, take your people, and have the guts to start.
That is Peter Van Hersel, head of BU Coding Solutions at Dorfner. Peter, thank you so much for being with us today.
Thank you for having me.
David, do you have an action item for us today?
Yeah, I think like any change, finding the people that are passionate about it is really a key to making sure you're successful. So find those people and give them the space and the time they need to actually do the job.
Wonderful. That is David Thomas, Director of Research Development at Syensco. David, thank you so much for being with us.
Thank you.
And Kyle, now Kyle, I'm wondering if you have an action item for us today.
I love what Peter and David said. 100% agree with both of them. I would say take the 10 minutes before getting started and identifying the right people to think about what are the outcomes. Write it down on paper. What are the outcomes that we would hope to see using AI? Because if you don't start with that North Star, you can find the right people, you can start executing, but you'll very quickly find yourself lost. So it would encourage everybody, just get clear on what their definitions of success and using AI are. And if you don't know what's possible, I think you can very quickly get a decent understanding by a little bit of internet sleuthing and research, or come talk to us.
That is Kyle Killebrew, Chief Operating Officer at Citrine Informatics. Kyle, David, Peter, thank you so much. What a great panel today. Your perspective and advice are spot on. I hope that we'll get a chance to talk again soon. And to everyone joining us today, thank you too. You can join us again next time on October 16th with a great panel of guests discussing the topic of shaping your organization's AI strategy to solve real-world challenges. Now that should be another great discussion. And in the meantime, if you'd like to find me, you can do so on LinkedIn. I'm happy to connect there, so check me out. I'm Kevin Crane, and you can check out my weekly audio podcast, the Digital Transformation Podcast. But for now, that'll do it for this episode of AI Talk, and until next time, I am Kevin Crane saying thank you for watching.